Now that you have been instructed on the different types of designs and their functions, let's discuss the particulars of how to conduct the single system design. The length of the baseline is important, and it should be long enough to establish an assessment of what the behavior looks like. However, we must be practical and ethical in determining how long we monitor the behaviors. The golden rule is to obtain at least 3 observations during the baseline. Usually, the worker would schedule to see the client every week. Therefore, the worker would choose a behavior to monitor that would occur at least 3 times in 1 week, or more likely, the client would monitor the behavior every day. If the client has suicidal ideations without a plan, obviously we would not use a baseline, but would start the treatment immediately. Clients often enjoy monitoring their behaviors and enjoy seeing their progress as indicated on a graph. Therefore, the graph is shared with the client and is used as an intervention tool. I mentioned before that the worker monitors the severity or magnitude of the behavior. In addition, the worker may monitor the frequency of the behavior. For example, little Johnny might engage in fistfights on the playground at school. The teacher may monitor how many fights John starts each day. For the individual who is depressed, the client may monitor how long he or she engages in self-deprecating thoughts. In addition to monitoring frequency, duration, and magnitude, the worker will also evaluate the trend of these descriptors to determine their stability. There are 2 methods to indicate if a statistically significant change has occurred between 2 different phases. The first procedure, to determine statistical significance, is called the 2 standard deviation procedure. The behaviors must be measurable, and for this procedure, they must be at an interval or ratio level. A statistically significant difference occurs if there is a 2 standard deviation difference from the baseline mean and the intervention, which would represent being in the critical region that contains less than 5%. Remember our normal curve and critical regions. First, we determine the mean score of the baseline data points. Next, determine the mean scores of the intervention data points. Next, subtract the mean score of the intervention phase from the mean score of the baseline phase. Divide the difference by the baseline standard deviation. You will need to go back to the textbook to remember how to calculate the standard deviation. The quotient represents the effect size, or Cohen's d. In this example, the quotient is 2, which is 2 standard deviations, representing a statistically significant difference in the baseline scores and the intervention scores. Let's use a real-world example. Little Johnny has difficulty with temper tantrums. One way of calculating your means and standard deviation is creating 2 variables, A phase and B phase, and entering the data or frequencies for each phase in an SPSS data file. You can conduct an analysis of the means and standard deviations. Having calculated our means and standard deviation, we use the formula and find an effect size of 7.55. which is greater than 2 standard deviations, or the criterion indicating a statistically significant difference from baseline phase compared with the intervention phase. Good for Johnny. The other method, and one that is much preferred, is the X-moving range 3 standard deviation, or XMR chart. This method requires behaviors at the interval or ratio level. This method uses more stringent criteria as it requires 3 standard deviations from the baseline mean and considers the instability or fluctuating patterns during the baseline. If the data points during the intervention phase are 3 standard deviations away from the baseline mean, the p-value is at the 0.0027 value, a value that is more rigorous than the 0.05 level. Step 1. Calculate the baseline mean by dividing the sum of the scores by the number of observations. Step 2. Calculate and sum the ranges of each pair of adjacent data points, ignoring any minus signs. Remember, there is 1 less than the number of data points. Step 3. Calculate mean range by dividing the sum of the ranges by the number of data points. Remember, it is 1 less than the number of data points. Step 4. Calculate the standard deviation by dividing the mean range by a correction factor of 1.28. Step 5. Multiply the standard deviation by 3. Let's try an example. First, we calculate the baseline mean by dividing the sum of the scores by the number of observations. Our sum of the baseline is 50 divided by the total number of data points, which equals 10, resulting in a mean score of 5. Next, calculate and then sum the ranges of each pair of adjacent data points, ignoring any minus signs. Remember, there is one less than the number of data points. The total is 13. We calculate mean range by dividing the sum of the ranges by the number of data points. Remember, it is one less than the number of data points. Instead of 10 data points, we would divide by 9. Therefore, 13 divided by 9 equals 1.444. Calculate the standard deviation by dividing the mean range by the correction factor. 1.444 divided by 1.128 equals 1.28. Finally, multiply the standard deviation by 3. 3 times 1.28 equals 3.84. The mean baseline score is 5. For Johnny, we would like his behaviors to decrease. Therefore, we want to find out if he has any data point 3 standard deviation points below the baseline mean during the intervention phase. We draw a line at the 1.16 frequency line. Johnny has 2 data points at a frequency of 1. Therefore, we have 2 data points below the 3 standard deviations below the baseline mean, meaning that the client demonstrated statistically significant changes during the intervention phase. Our interpretation includes a statement of the type of design used, the behavior monitored, a short description of the client, the length of the A phase, the frequency, duration, magnitude, and stability of the behaviors during the A and B phase, with an overview of the findings for the X moving range 3 standard deviation procedure. We can use a proportion frequency procedure for nominal or dichotomous variables. This procedure requires us to use the proportion of desired zone data points between baseline and intervention periods table found in Rubin's book on page 247. Using the table, we need at least a proportion of 0.50 intervention, or half of the data points in the desired zone, to be statistically significant at the 0.05 level. For example, if we have 10 data points during the intervention phase, and we have 5 yes responses that the client performed a behavior that you and the client agreed for them to do, we would say that they engaged in 0.5 or 50% of the time in the targeted behaviors. Looking at the table, if there are 10 data points during the intervention phase, and there are 0.20 or 20% of the desired behaviors occurring during the A phase, we would desire 0.5 or 50% of the intervention scores to be in the desired yes zone. And that's exactly what happened. The table shown in the PowerPoint is based on an alpha level of 0.05. Therefore, a statistically significant difference occurred.